Hello everyone. In this video, I'm going to explain what is virtual private cloud, what are the key components of virtual private cloud, and benefits of virtual private cloud. Firstly, let's see what is virtual private cloud. So, VPC is a AWS service that allows you to launch a AWS services in a virtual network that is logically isolated and defined by the users. And VPC provides a complete control over the virtual networking environment. And VPC provide an extra layer of security and control over your resources and allow organization to define their own private IP address space and create a subnets and configure routing tables and set up network gateways. So let's see what are the key components of VPC. So first one is subnets, route tables, internet gateway, NAT gateway, elastic IP addresses, security groups, and the network access control list. So in the upcoming slides, let's see key components of VPC in detail. Let's see what is VPC subnets and the IP addressing. When you are create your VPC, you specify its set of IP addresses within the CIDR notation. CIDR stand for Classes Interdomain Routing. Notation is a simplified way to show a specific range of IP addresses. For example, 10.0.0.0/16. That means all the IP addresses from the 10.0.0.0 to 10.0.255.255 comes within this CIDR notation. So how does that work? How does the 16 define? Let's see. The range of IP addresses covered by the 10.0.0/16 goes from 10.0.0.0 to 10.0.255.255. It's allow for a total of 2 to the power 16, that is 65,536 possible IP addresses. You can create a 65,536 possible IP addresses within this CIDR notation. So let's see how the IP addresses works. So every set of 4 digits in a IP addresses represent a set of 8-digit binary values. So this is how you can represent IP addresses in the binary values. So you can represent the 10 like this: 0001010. Let's see what is route tables. In a VPC, the route table is like a map that tells your traffic where to go. It contains a set of rules called routes, which direct which directs the traffic from your VPC to various destinations like internet, other VPCs, or your own data center. So each rules in the route table has a destination, a range of IP addresses called CIDR block, and the target. So where to send the traffic. When data leaves your EC2 instance, the route table checks the destination of the data and compares it to the routes in the table. So based on the destination, the route table sends the traffic to the right place. Now let's see what is security groups and the network access control list. So in AWS, both security groups and network access control list are the essential for controlling access to the resources within a virtual private cloud. So security groups are associated with EC2 instance and control traffic to the and from this instance. So if you want to create a security groups, you have to follow these rules. So firstly, you have to mention the protocol like TCP, UDP, SSH, or HTTP like that. So and you have to mention the port number and also a source or destination IP addresses or the CIDR block. So let's see how network access control list works. So in a AWS, Network access control is a firewall like security layer that control traffic in and out from the subnet. Both inbound and outbound roles must be explicitly defined. If you allow incoming traffic, you must allow outgoing responses. So network access control list operates at the subnet level and control traffic to and from the subnets. Now let's see what is internet gateway. An internet gateway allows communication between the instance in your VPC and the internet. So it is typically attached to a VPC and enables public access to the resource that have a public IP addresses. To use an internet gateway, you must have a route in your route table that directs internet bound traffic like 0.0.0/0 to the internet gateway. So it handle the both incoming and outgoing traffic to and from the internet. So let's see what is NAT. NAT gateway. So NAT gateway stands for Network Address Translation Gateway. Is a managed service from the AWS that allows you to instance in a private subnet to connect to the internet. It does the without exposing the private IP addresses of your EC2 instance. Typically used when you want to allow private subnet resource to the access the internet for the updates or the downloads, etc. It only allows inbound outbound traffic to the internet. Responses to those requests can come back through the NAT gateway. To use the NAT gateway, you need to update the route table of your private subnet to route internet-bound traffic to the NAT gateway. So this is the example architecture of the VPC. So here you can see the outbound line is like your AWS account. Within that account, you have to create your VPC. This is the VPC. So for the VPC, you have to mention CIDR notation. Within that VPC, you can create two subnets. That is one is public subnet and another one is private subnet. So within that subnet, you can install EC2 instance. So you have to create a route table to control the traffic. So whatever the request come to that EC2 instance, it must comes through the route table. And if you want to access the internet for the public subnet, you have to create a internet gateway and you have to attach it. Now let's see benefits of VPC. First one is security. A VPC lets you create private secure section of the cloud where you can control who can access your resources, so you can monitor and filter incoming and outgoing traffic to protect your systems. Next one is customization. You can set up your network the way you like by choosing IP, creating smaller network and deciding how data moves between your network. Next one is network monitoring. So VPC flow logs keep a record of all traffic in your network, helping security teams to spot unusual activities or troubleshoot problems. Next one is scalability. So VPC allow you to easily or add or remove resources in a real time based on your needs and allows you to network to grow or shrink as required. Internet access. So VPC lets you connect securely to the internet and others cloud services. You can have a public subnets for things like websites and private subnets for sensitive resources like data centers. Next one is automation. Tools like Terraform can automatically set up connection between your VPC and reducing the chances of mistakes and making easier to manage. And next one is Elastic IP. There are permanent public IP addresses that you can move between different servers or ensuring your services reachable even if something changes. So these are the benefits of using VPC. Now let's see what are the pricing for the VPC. So in a VPC, prices are various depending on the cloud providers you choose, such as AWS, Google Cloud, or Azure. Here the general breakdown of the components that affect the VPC pricing. First one is data transfer. The cloud providers apply charges for the data transferred out of the VPC to the internet or other regions. Ingress is often free, while egress usually incurs fees. The next one is subnets. Creating a multiple subnets within your VPC may have associated cost depending on how they are used and resources within them. The next one is elastic IP addresses. The charges for using static IP addresses, especially if they are not associated with within a running instance. The next one is NAT gateway. So fees for using NAT gateways to allow instance in a private subnet to access the internet. And the next one is VPN connection. Cost associated with the establishing a VPN connection for secure communication between your on-premises network and the VPCs. And the next one is load balancer. So pricing for load balancing solutions used within the VPC to distribute incoming traffics. And next one is storage. If you are using storage options like EBC volumes in AWS, there may be cost associated with the storage you provision. So far you have seen how the VPC work, what are the key components of VPC, and the uh, what are the benefits of VPC, how the pricing are work for the VPC. So thank you guys for watching this video.